Well, hello and welcome everybody to Science. Happy Friday. You made it. Another great week and a 3-day weekend coming up. So let's put all our energy into finishing this afternoon strong, and then we'll go take a well-deserved 3-day weekend. Today, we are comparing dissolving and melting, two phenomena that you have looked at in science before, in, well, dissolving this year and then melting in past grades when we were talking about different states of matter. Okay. Here's the materials you're going to need today: your science notebook, pencil or pen. Additionally, there is a data table in the Google Classroom exit ticket. If you want to pull it up and fill in directly into the exit ticket as you go, that's great. If you prefer to put it on paper, then the table is there for you to copy into your science notebook. Additionally, I will be putting the data table up later for those of you who maybe, aren't from the tacos class and are just visiting and getting some extra science learning, and you want to take some notes anyway. And then down here are the I cans. I can observe a scientific phenomenon. I can compare how different solids react to heat, and I can explain the difference between dissolving and melting. So, here's our focus question. Are dissolving and melting the same thing? We've been talking about dissolving a lot, where a solute, so just some sort of substance, almost seems to disappear and be incorporated into a solvent or something that's being dissolved into. But it's not actually disappearing, as we've seen from our experiments where we've evaporated back out the water to get that solute and be able to see that solute again. And in fact, we're going to see that later this afternoon with the results of evaporating those saturated solutions that we made last week. And what's really happening inside a solution is things are kind of spreading out. So, essentially, if taking salt, for instance, we've worked with salt water solutions a lot. So as the salt gets mixed up and mixed in, it breaks down into, or disintegrates into, smaller particles, smaller little tiny grains of salt, and those kind of get dispersed within the water, so much so that we can't see it with our eyeballs anymore. If we put saltwater solution under a microscope, would it look different than fresh water under a microscope? You can leave that answer in the chat, because we're not going to answer it today. But today we're going to look at something a little different, and we're going to do some comparing. Okay? We're going to be looking at 5 different substances, and we're going to be actually looking at what happens when they're exposed to heat. In this case, some hot water that I made here in the kettle here. To any other Glenview teachers watching, yes, I did borrow that kettle from the staff room. I'll put it back, probably. Anyway, we're going to be looking at 5 different substances, and I'm going to put the graphic organizer up so you can see them. They are as follows. Boom. They're right there. Okay, so here's your data. I'm just going to do a big lean here to stay in frame. There we go. So these are going to be the 5 substances that we're going to be looking at. Okay, one of them is, the first one at the top, chocolate. We're going to be looking at some chocolate pieces there for baking, seeing what happens. We've got some butter. In this case, it's the kind of spreadable kind. It's good for toast. Okay. We've got wax. In this case, there are some birthday candles. A happy early birthday to you if your birthday's in January, of which we have a few. We've got some pebbles. We remember these from our first investigation of this unit on mixtures. And we've got our old dear friend salt, because we know what happens when salt dissolves in water, and we want to see what happens when it melts, if it melts. Okay, so what we're going to do is this. I'm going to move this out of my face briefly. Hello, back again. Essentially, this is going to be the setup for our investigation. We have some empty containers here that we're going to fill with hot water. Then we're going to take our test objects and we're going to put them in the container just like this. You see there's a little space at the bottom. So there's going to be hot water in here. And because we want to be able to separate out what's dissolving from what's melting. Okay, so in this case, we don't actually want to put our materials directly into our hot water, because then who's to say if they're melting or dissolving and what's causing any change we might see. Okay, so it's going to kind of nest on top like that. If you've ever melted chocolate for baking, it's kind of a double boiler here, right? And then we're going to wait for a few minutes and we're going to see some change. Okay, so I'm going to set that up right now. Let me pull up actually the graphic organizer again. While I'm doing this, your job is to do two things. One, make a prediction in that middle column. What do you think will happen when each of the materials interacts with hot water? Chocolate, butter, wax, pebble, salt. Okay, so make your prediction. What do you think is going to happen when the chocolate and the hot water interact with each other, the butter and the hot water, the wax and the hot water, pebble, salt, etc. And then that bottom column is the hot water temperature, which I'm going to tell you in just a second once I pour this water. So you should be making your predictions right now while I set this up. Okay. And I'm dropping my thermometer in. Here's my thermometer. There it is. Putting it in our hot water. And this is going to be in Celsius, by the way. Just letting you know. Almost there, almost there, almost there. And we have it at 75 degrees Celsius. So I'm actually going to just type it right in here for us. 75 degrees Celsius. Oops. Nope. How do you spell Celsius? I think I was right the first time. I think I just spooked myself. 75 degrees Celsius. Okay, so now we're going to put each of our materials in, and then we're going to wait. So you have some more time to make your predictions here. Ta-da. Chocolate is going in our tub. Okay. Butter. So here's what it looks like to start. We've got our wax candles, 2 of them. Whoop, they're flying out, blue and a gray. Ta-da. Okay. We've got our pebbles that are going to go in some hot water. And we've got our salt. Okay. While we're giving some time for our chocolate and our butter and, ooh, something's already happened to the butter. I'll show you in a second. And our wax and our pebbles and our salt. Just to compare, I want you to see what they look like in room temperature water, because, you know, we saw what salt does when you add it to room temperature water. You saw how many degrees Celsius in? 75 degrees Celsius. We saw what salt looks like when we mix it up with water. We saw what pebbles look like when we mix them up with water. Okay, we haven't seen the other 3 yet. So let me just show you. Here's our candles. Tilt this down a little bit. Here are candles in water. Our wax in room temperature water. Have they dissolved? No. It's starting to smell like weird popcorn in here because of the butter. Also, bonus question. Are the wax candles more or less dense than the water? Put that in the chat. Okay. Next, we've got some butter in water, room temperature water. Okay. what's happening to that butter, right? I don't see really any chunks, no disintegration yet. Maybe a tiny bit, but not a whole lot of change. And then we've got some chocolate. And I am noticing, oh, look at that. See how our water's turning a little brown? It is starting to break down a little bit, if we can see in there. Compare that to our wax water. Definite change in color there. Definite darker because of that chocolate that's in there. So a little bit of dissolving happening with chocolate. And anyone who's made chocolate milk or hot chocolate will tell you that chocolate does break down in water. Okay, so let's take a look. And I'm going to pull our graphic organizer back up just briefly. So again, we're making a prediction for our chocolate, our butter, our wax, our pebble, and our salt. And we're going to take, let's see, do I have one close? One thing that I forgot to grab is a popsicle stick, because I want to do some poking. So I'm going to grab a popsicle stick. You're going to come with me. Ta-da, do-do-do. There we go. I do want to do some poking. If we were in the classroom, we would be allowed to poke, but not to taste. In this case, all right. So the first one we're going to look at, let's look at actually the most glaring one here. Okay. We're going to start with our butter. What was your prediction for what would happen to our butter in hot water? 75 degrees Celsius water. Survey says, I'm going to try not to make a big mess. Would you look at that? We've got a full-on melt. What has happened? When we say melting, what are we thinking about in scientific terms? All right, when we say melting, a substance has melted. It has started as what? And then has become what in terms of our states of matter, right? It started as a solid, and now, what is it? Right? When we say melt, that's what we're referring to. When something starts as a solid and then becomes a liquid, it changes matter, changes its state of matter. Okay? So, butter, very clear there. We've got a big melt going on with the butter. Very different from, right? Is our butter dissolving in water right now? No. Even if we gave it a stir, I'll give it a stir. Has it dissolved? No, it's kind of breaking up because I'm stirring it. I bet if we ran this through a filter, we'd be able to get that butter back out. Yeah? Okay. Now let's take a look at, which one should we do next? Pull the graphic organizer back up here. Our butter melted, became liquid. Put that in parentheses because that's what melt means. Okay. And next we have, let's take a look at something different. Let's take a look at our pebbles. Didn't we, or pebbles are gravel. It's gravel, technically. I think I put pebble on the graphic organizer, but technically it's gravel. We learned about that last year, so I should be scientifically specific, shouldn't I? No change here. I'll even poke it. Maybe they got soft or something. Let's see. It doesn't really sound like they got soft. No. No change for our pebbles. Question that you can put in the chat as we collect our data here. Could we get pebbles to melt? What would we need to do to get pebbles to melt? They didn't melt in 75 degrees Celsius water, but could we get pebbles to melt? Put that answer in the chat. Okay. Pebbles. Technically, it's gravel. But you can keep it as pebbles because it's both rock, just different sizes. No change. Okay. Matthias and Mars say, yes, you could get pebbles to melt if it's really, really hot. And yes, I would agree. Because what's our name for rock in liquid form? We learned that in 4th grade. Hello. All right, next we've got, let's go the candles next. Let's go the wax. Okay, so here is they still look like candles, for sure. One thing I'm noticing is, remember when they rolled out of the bin? They're not doing that anymore. Let's grab our stick and do some poking. They have definitely gotten softer. You see how I can just gently kind of poke my popsicle stick in there and they get stuck, and there's actually, you see, there is actually a little bit of melting going on. See that little bit there at the top? Those little white stripes off of our blue candle. So there has been some change. No complete melt, it's still solid, but they have definitely softened. So we want to make sure to put that on our graphic organizer. Okay, so the wax has softened. Softened, no full melt. Okay? 2 more. Should we go our salt next? Let's go our salt next. Let's see here. Okay, here's our salt. And do some poking. I don't see an observable change here. I think we've got no change with the salt. You know why? Because salt's technically a rock. It's a mineral, technically. So could you melt salt? Yeah, same thing as the gravel. It just need to be real hot. Okay. Ta-da. Salt. No change. So that's what we're at so far. Last one, the chocolate. Here we go. Chocolate out. Let's take a look. Here's what we've got. So, still holding their shape. Let's do some poking. Aha. We have gotten much softer. I might go so far as to call this a full-on or close to a melt. Right? Definitely softer than the wax. Not as soft as the butter. The butter was a full-on liquid. This is still very viscous here. Throwback. Any of you that had me in 1st grade know the word viscous, because it's a fun word to say when you're 6. All right, very, very melty. Not quite like as thin as the butter, but still very melted. All right, so let's capture that on our graphic organizer. Very melty, more viscous than butter. Okay. And if we went back and we looked at the chocolate in our room temperature water, just as a comparison, right? Where'd my stick go here? Let's do some poking on this one, see if it got softer. It's starting to break into pieces, but it's not turning into liquid it's not really becoming kind of a goop like our chocolate was when exposed to the hot water. So what's happening right now is this, rather than dissolving, this is disintegrating, meaning it's breaking into smaller pieces. Okay, whenever something breaks into smaller pieces, we call that disintegrating. It's a little different from dissolving. And dissolving really gets kind of incorporated and spread out in the solution. Okay, so we've got some disintegration there, but not a dissolve. So let's think about now the differences between melting and dissolving. The biggest one is, well, what was causing our chocolate and our butter and kind of our candles to melt? So our candles were on their way there. They weren't there yet. I bet if we gave it more time in the hot water bath, we'd get some melted wax. What's causing that change to happen? Is it the water? Or is it something else? It's not just water, right? It's what? It's the heat. Yeah, it's the heat from our hot water. We could use any type of heat source. We could use any type of heat source to melt butter or to melt chocolate or to melt wax, right? Or to melt rock. We would just need a heck of a lot of heat. And it would be a really, really high temperature, like thousands of degrees, but it can be done, right? That's how glass blowers make glass vases and glass sculptures, is they heat up glass, a mineral. They heat up glass to a very, very high heat and get it to soften up so they can mold it, right? Which is different from dissolving and making a solution, because that's two different substances interacting, whereas heat is really just energy in this case, right? It's not like we're making a mixture of heat and chocolate. It's that the heat is changing the state of matter with the chocolate. It's making our at a molecular level, it's making everything kind of speed up, which makes it lose its shape there. Okay. One other question to think about in our exit ticket is this one. Let's go back to our melted chocolate here. When this chocolate melted, did it lose mass or gain mass? Was there any change? We've been looking in our solutions about how, the mass of 50 grams of saltwater solution is more than 50 grams of, or 50 milliliters of a freshwater, of freshwater, right? We've seen that 50 milliliters of a citric acid solution has more mass than 50 milliliters of a saltwater solution. So is this gaining or losing mass, or does it have the same mass just in a different shape? I'll let you make an inference about that one on the exit ticket. Thank you all for tuning in. I really appreciate this hard work on a Friday afternoon. I hope this was a worthy substitute. If we were in the classroom, we'd all be getting to kind of get hands-on with this stuff. And so that's one of the unfortunate things about distance learning, but I'm hopeful that we're still able to kind of grasp the concept and get some observations in a virtual realm. All right, thank you everybody for tuning in. And exit ticket, tacos, go do the exit ticket now in order to play at game time this afternoon. Do that exit ticket. Everybody else, guests, Schenker Johnsons, I know some of you are here. Thank you for tuning in. You've got your own work to do. Everybody else out there in the wide, wide world of the internet, thank you for tuning in and learning some science today. We will see you next week with some more fascinating